Okay, this is 7.2, Properties of Parallelograms. The essential question you will be answering at the end of this is what are the properties of parallelograms? What you are expected to learn is to use the properties to find side lengths and angles of parallelograms. You're also going to use parallelograms in the coordinate plane. First vocabulary word for this is a parallelogram. And if you recall, it's simply a quadrilateral, which is a four-sided shape with both pairs of opposite sides parallel. So if I draw two horizontal lines, kind of a little bit staggered, okay, and then I connect those two sides, these two would be parallel to each other, and the two slanted sides would be parallel to each other. Okay. This would be an example of a parallelogram. You could name it A, B, C, D, and then when we're writing it, we usually draw a little smaller parallelogram type shape, and then we put just the letters, the vertices. So this would be parallelogram A, B, C, D. Okay, next we have the parallel opposite sides theorem, and what that simply says that is if you have a parallelogram, then you know that the opposite sides are congruent. So if I draw a parallelogram, so I'm just call it Q, R, S, and P. And that means that these sides here that we had marked previously parallel, they're also congruent to each other. And the two slanted sides would also, that are parallel, would also be congruent. Okay, so I would know that segment QR is congruent to segment PS, and segment QP would be congruent to segment RS. Another property that we have with parallelogram is that the opposite angles are congruent as well. So if I redraw this parallelogram right quick, let's see, let's call it QRSP again. Then that would mean that P is congruent to R, and Q would be congruent to S. Okay, so let's go ahead and write that out in symbol notation. There you go. On our first example, we want to find the value of each variable. So they gave us a parallelogram. We got variables everywhere, but three of them have x's, and then we just have this one that has a y. Because of the theorems that we just got through writing, we know that opposite sides are congruent. So that means that my x plus 18 has to equal my 3x minus 2. So that's what I'm going to solve first. I get my variables on one side, so subtract x from both sides. Then I get 18 is equal to 2x minus 2. Add 2 to both sides. I get that 2x is equal to 20. Divide by 2 tells me that x is equal to 10. Okay. So I know the first answer, x is equal to 10. Now I'm going to solve for this y down here. Since opposite sides are congruent, I know that this segment up here on top is congruent to the segment down here on bottom. And that's important because now that I know what x is, I can substitute in 10 in for x. So I have 4 times 10. So I know this top length is equal to 40. And since opposite sides are congruent, that tells me that y must be 40. So for this example, y is 10 and x is 10 and y is 40. The next theorem we have is what's called a parallel consecutive angles theorem. and that just says if a quadrilateral is a parallelogram, then we know that its consecutive angles are supplementary. So if I look at this parallelogram as my reference, that tells me that the measure of angle Q, whatever that happens to be, plus the measure of angle R is going to equal 180 degrees. Okay. So I can add these two. Consecutive means that they're they're connected to each other. So Q and R would have to add up to 180. I could also say the measure of angle Q plus the measure of angle P would be 180 degrees. Okay, that would be another example, because I know these two, they're on the same side of the parallelogram. Okay, and the same thing for P to S. P and S would be supplementary. S and R angles would be supplementary as well. Okay, the parallel diagonals theorem says that if a quadrilateral is a parallelogram, then its diagonals bisect each other. Right, now, if you remember, the diagonals connect opposite sides. So Q would connect to vertex S, and then P would connect to R. Okay, those are my diagonals, and they intersect at some points. We'll call that M. Okay, now that tells me that QM is congruent to SM, and PM would be congruent to RM. So this part would be congruent to this part, and same thing on the other diagonal. This segment would be congruent to this segment. Alright, for this example, we have these diagonals that are drawn, and the theorem says that the diagonals bisect each other. So that tells me that this piece right here, from this vertex to that intersection point, has to be equal to this opposite vertex to that intersection point as well. So I'm going to go ahead and solve for y first by setting 5y minus 16 equal to 3y. Okay. Then I'm going to subtract the 5y. So that tells me negative 16 is equal to a negative 2y. I divide by negative 2, I get that y is going to be equal to 8. Okay, so that's the first answer. Y is equal to 8. Now, on the opposite side, for my x's, it's the same thing. I know that this one is congruent to that one. So I'm going to go to 2x plus 10 is equal to 4x minus 2. I subtract 2x to both sides. I get that 10 is equal to 2x minus 2. I add 2 to both sides. That gives me 12 is equal to 2x. Divide by 2 tells me that x is equal to 6. Okay, in this next set of examples, we got to find different parts of this parallelogram. The first example, it asked me to find the distance from P to O. PO is down here, and because the opposite sides of a parallelogram are congruent, that tells me very easily that PO, the distance from P to O, is 24 units. Alright, this example asked me for the measure of angle PMN. PMN is this outside angle here. Okay. Now, I do know this angle here is 68, and so the consecutive angles are supplementary. So that would mean that to find this angle, I would do 180 minus 68, which would give me 112 degrees. On this one, they're asking us to find the measure of angle NOP. That's this bottom angle down here. Now, I already know that I have 59 on it, but that doesn't give me anything down here. So what I do know, again, is the 68 degrees is here. These two would be consecutive angles. So then what I would do is 180 minus 68, which gives me 112. So the measure of NOP would be 112 degrees. Okay, on this example it says find the coordinates of the intersection of the diagonals of parallelogram element O with the vertices Here 1, 4, 7, 4, 6, 0, and 0, 0. I went ahead and graphed it for you. Now remember that the diagonals bisect each other. So what you're looking for is, if it's bisecting, you know that these two pieces are congruent here and here as well. And then so what you want, since it's bisecting, that tells you that this point here, whatever this point happens to be, we'll call it Q, that's going to be the midpoint of either diagonal. So what I want is I can do the midpoint for L and N, and I'm looking for, or I could solve for the midpoint of O and M. Now, since one of the points is at 0, 0, that's the easier one to do. So I'm going to use M and O. I'm going to use this one and this one to find my midpoint. Okay, so what I would do, using the midpoint formula, is that I would take 7 plus 0, divide by 2. Then I'll take 4 plus 0, divide that by 2. 7 plus 0, 0, obviously, so that's 7 halves. This would be 4 over 2. And that's going to be 7 halves. 4 over 2 would reduce down to 2. Okay. So that would tell me that that's the coordinates of the intersection right here. This would be the answer. Alright, this example says 3 vertices of parallelogram WXYZ are -1, -3, -3, 2, and 4, -4. And we want to find the coordinates of the fourth vertex. So first thing to do is to graph this. -1, -3 would be right here. That would be our W. X is going to be at -3, 2. Should be here. And then Z is going to be at 4, -4, which would be down here. Okay, so I'm going to kind of go ahead and start drawing this just so we can kind of connect it and see what's happening. And so I need to figure out where this other point is going to go, this Y. Right? Now to do that, I know that opposite sides are parallel, because that's part of a parallelogram. So the easy way to do this would be to find the slope of, say, this line right here, XW, the segment. And so to do that, we go up from here. We're going to go up 1, 2, 3, 4, 5 units. And then we go left 2 units. Okay. So to find Y, I'm going to do that same slope, but I'm going to do it from Z. So I would go up 1, 2, 3, 4, 5, and then I'm going to go back 2, which would be there. This would be my point Y, which would be at 2, 1. Okay?